Hello guys, today we're gonna try to transform some logarithm in the form of exponent. So this exercise is really important because most of the time when we resolve equations with logarithm, what we do in the first step, we try to isolate the logarithm in one side, like this one. That's in one side we have a logarithm, the other side we may have the number. And once we get there, once we isolate the logarithm on one side and the other side we have an exponent, like this example f, we got log x plus 7 equal 8. So when we get there, it's really, since we try to solve an equation, we just would like to have x to solve it without the log. See, so it's really important to know how can I get rid of the log. That means the technique is to transform the log in the form of an exponent. So you're gonna get rid of the logarithm, you're gonna end up only with this variable and the a number. So it's really important to understand how to transform a logarithm in the form of an exponent. That will help you a lot when you try to resolve some equation with logarithm. We got like here 7 examples. Each of them we got the logarithm. We're gonna try to write them in another form. Okay, but let's make a review. Remember what we said in the previous course. We said when we have, like this example, log base b of x equals c, so the result that we find is the power. So when we try to compute log base b of x, what we try to find out is the power. The c is the power. The result of a logarithm is the power, since this can be a reading like b to the power of c equal x. So again, when I try to compute log base b of x, what I'm looking for the power. So I'm asking to what power do I need to raise b in order to have x. So I need to raise b to the power of c in order to get x. So b to the power of c equal x, or x equal b to the power of c. That's simple. Understand it like that. Understand, because I said it before, I will say it again. When you try to compute log base b of x, the result, which is c, is the power. So what you're looking for, so to what power do we need, do you need to raise the base in order to have c. Understand the base can be 2, can be 3, the base can be 6, 5, but normally generally the base is positive. Okay, and also understand there is one exception. Sometimes when you have this logarithm ln, the base is e. Ln is like log base e. E is a number, the number e is a number, this number equal 2.71. So ln equal log base e equal ln, the natural logarithm. So like this example, I have a log base 5 of 125 equal 3. So as we can see, the question, to what power do I need to raise 5 in order to get 125? So 5 to the power of 3 equal 125, or 125 equals c. So if you understand this, it's going to be easy to solve those 7 examples. We're going to solve them step by step, each of them. Let's go for the first one. They are really easy. So this one, I have log 2 equal log base 3 of 9. So what I need to do, understand what I'm looking for. I'm looking for the exponent, the result with the exponent. So it's like, to what power, that means I need to raise 3 to the power of 2 in order to get 9. Okay, that's it. That's another way if you want to write this in the form of an exponent, you just say this equal 3 to the power of 2 equal 9. That's another form. Or the same to say also 9 equal 3 to the power of 2. That's another way if you want to write a logarithm, whatever the logarithm, in the form of an exponent. We have 7 examples. We're gonna do the example B. Since we already do the example A, let's do the example B. Let's do B here. Let me pass it here. That's B. Okay. The same here. The base is 91. So the base is 91. Understand? When you have a logarithm, this logarithm equal 1/2. So the question, to what power do I need to raise 81? No, to have 9. So it's like 81 to the power of 1/2. 81 to the power of 1/2 equal 9. It's the same to say 9 equal 81 to the power of 1/2. Okay, so I understand these examples are really important. So sometime when you're going to solve some equation with logarithm, we try to isolate logarithm on one side and the number on one side, and the next step is to convert the logarithm in the form of an exponent. That's why it's really important to understand this example. Let's keep doing them. We got this one. They are easy. Let me make a copy of it. Oh no. Here I got log base. Let me make a copy of this. Let me pass this here. Okay, here I have like let me just erase this. This is like I have a log base 2 of 16 equal 4. So the same process. To what I know the result, to what power do I need to use the base? In order to have 16 is like 2 to the power of 4 equal 16. Or I can say 16 equal 2 to the power of 4. Okay? So let's keep doing them. We'll do A, B, C. Let's do D. Let's do D. Let's make a copy of D. We're gonna solve D. Pass it here. So D, to solve D, what I'm gonna do, the same process. I know the base is 10. So understand, we say the result of a logarithm with an exponent is the exponent necessary to raise the base in order to get the value that you are trying to compute the logarithm. So this is like, oh excuse me, this is -3. In this example it was -3. So this is like 10 to the power of -3 equal 0.001. Or again I can say also 0.001 equal 10 to the power of -3. Okay, what we have next, we have this example. We did A, B, C, D. Let's resolve E. We're trying to do as much as example as possible so we'll be able to understand them. So okay, Okay, let's do this example. Let's move it here. I'm just moving this here in order to have some more space. So what about this one? Let's say I have an equation and I manage to isolate the log on one side and the number on the side. Once I get there, so I just want to have to this x equals something. So that's why it's really important to understand how can I get there. So remember what we said. So it's the same technique. So the result that you got, it's the exponent necessary to the base in order to get to x plus 1. So I can say it's like 2 to the power of 12 equal 3x plus 1. Or I can say also the same to write 3x plus 1 equal 2 to the power of 12. So starting there to be, from there it will be easy to solve the final value. Okay, so we already have a, b, c, d. Let's go for f. Let's go for f. I will let h for you. I'm just gonna solve f. So you're gonna try to solve by yourself h. So I did a lot of examples, so you can try to do the last example by yourself. So I'm gonna just do f for you, and by yourself you're gonna try to solve the last example, which is h. So remember that the same technique, once you isolate the log with one side, you should understand how to transform. So the result that you got from a logarithm, say it's an exponent. So the result is always the power necessary to raise the base in order to get the value that you are trying to find the logarithm. So okay, so I understand for this example you should remember that ln, what we call the natural logarithm, is log base e. So the base is e. E is a number. We call it the Euler number. This number is approximately 2.7182. Approximately. It's an irrational number. So now the same process I'm gonna do. Remember, the result of a logarithm is the exponent necessary to raise the base in order to get x plus 7. So the base here is e, so this is log base e. So the base is e, say e to the power of 8 equal x plus 7. Easy now, it's really easy. So I can say x plus 7, the same thing, x plus 7 equal e to the power of 8. From there you will easily find x. Since you know e equal 2.7, you just use your calculator. You did it and you minus 7, so you know here x equal the final result. If you want the final result, x equal e to the power of 8 minus 7. Since if you put minus 7 on both sides, you will get this one. So this is your final result. Use your calculator. This is your final result. Is your final result. Okay, so So understand why we make those examples. We said before, most of the time when you try to solve some equations with logarithm, the strategy is to isolate, to have a logarithm on one side and a number on the other side. Once you get there, you're just gonna use this formula. We're gonna use them, and so we're gonna find x. I hope this video was helpful. So see you in another video when we will keep working around the logarithm. We're gonna do another problem around logarithm. See you for my next video. Thank you.